Hello, my name is Sarel Chan and this is a video demonstration on the 7th laboratory activity, loops. So let's begin by opening it up LabVIEW and creating a new project. Blank project, and we'll be adding a new virtual instrument. Control T to display both windows side by side, and the block diagram will be creating a converter, converting from seconds to its corresponding hours, and we'll be adding the remaining seconds into minutes and the remaining seconds. So first, we'll be adding the division module, specifically a quotient and remainder component, since there are two division operations here. We'll be selecting the quotient and remainder specifically. So we'll be having two of them. Copy and paste. Next is for the first component. We'll be adding in our x. So the x in, we'll be right clicking it, and we create a control. This control will be our current number of seconds, or given. So we untick the view as icon to make it smaller, and let's rename this into seconds. We move it over here. Next, for our y value, our y in, we'll be creating a constant. This constant will be set to 3600, since our seconds, when converted into hours, we'll be dividing it into 3600 seconds. So our quotient right here on the bottom, creating a indicator. This indicator will be our hours, and for the remaining time, we'll be connecting it as an input for x. The remaining time that would not be converted into hours will be converted to minutes, and to convert seconds to minutes, we'll be dividing it to the constant 60 seconds. I'll be arranging this a little bit. That's better. So our quotient will be the seconds turning into minutes. Oops. And of course, the remaining time, or the remaining value, will become remaining seconds that could not be converted into either hours or minutes. So let's rearrange here our front panel. So let's say we have 90 seconds, and we'll be converting them into these particular values. So when we run, there we go. 90 seconds is converted into 1 minute and 30 seconds. So another value in place would be 2000 seconds. 2000 seconds would then be 33 minutes and 20 seconds. Let's aim for a larger number. 5,000 seconds. Another run will convert 5,000 seconds to 1 hour, 23 minutes, and 20 seconds. So that's the base result coming from our block diagram. Next we'll be adding the loop function. So here in programming, we'll be using the while loop. So let's encompass our converter into this while loop. Then we create an indicator. This indicator will call it current iterations. On our front panel, we have our current iterations. This will display the nth iteration that's happening within our while loop. Here, in our loop condition, we create a control, which is basically our stop button. So clicking our stop button on the front panel will basically just make our loop stop. So here, let's reset it to 0. Let's run our VI. So here we have our while loop running. We change the total time in seconds, and we see it's sort of real time. It changes, converts are given. And see, without clicking the run button, our block diagram is still running. And still keeps running. It's sort of a real-time running since it's inside the while loop. The while loop, it essentially loops until a break condition occurs, which is our stop button right here. So here it will keep converting or running the many iterations inside until we click our stop. And see, our entire while loop has stopped. So to see what actually happens in our block diagram, we can click highlight execution, which shows us the sort of direction of each of our data here. So here, let's give this value of 9,000 or some random number. So we click run with our highlight execution toggle, and here we see some bits of light moving. Those represent our data. And we see how our data moves, where each of those bits of lights go to. And here we also see the current iterations. It also passes data. It passes the data 12 and it outputs here. We also see here with our stop control, it keeps passing the Boolean false into our loop. Into our loop. And that is because we haven't passed or clicked the stop button, which passes a Boolean true function. Boolean true value, I mean. So when we hit stop, it will pass Boolean true, which stops the operation. Additionally, to increase the significant numbers displayed for current iterations over here, you could just right click the indicator, its properties. We have the display format, and we change it to decimal. And here we won't have a limit, since the default was floating point. Its limit of digits is only 6, and if we go to decimal, it nullifies all these. We can expand so that we can view a lot more numbers. Next is we'll be adding an indicator for the total number of iterations that this while loop has done. So first we'll be moving this. So the sort of formula for our total number of iterations would be the current number of iterations plus 1. So we go to the mathematics, numeric, and our increment, which is plus 1. We place it here, and we connect our data here, current iterations, to our x here. Then we'll be placing an indicator, total iterations. There on our front panel, have it. Let's make this a bit small. There we go. And similarly, what we did with the current iterations, we'll be changing its number type to decimal, as to not limit the number of significant digits that it displays. So here we'll not be highlighting, as to see its how it currently works. So we'll be placing 4 and a random number of zeros. So we make it run. Here we see it just works as usual, but our total number of iterations does not change. This is due to the fact that the total number of iterations operation, or our increment function here, is placed outside the while loop. So we stop our operation, and we see when we stop it, it displays the total number of iterations. we can see it better when we highlight each execution, which actually displays how each of our data is moved around the block diagram. So here we run our block diagram with the highlight execution toggle. Here we see each of our data still moving as usual, except for here. Our current iterations that was connected to our increment function. And once we stop our loop, it passes it through. And as you see, the data here in our input tunnel, or rather output tunnel, is passed. This is because it's sort of like a gate of sorts. When our while loop is running, anything passed to the gate will be stuck, sort of stuck or stopped there until our loop stops. We can test this out with our control here, our total time in seconds. So we move this a little bit closer. We move this, oops. We move this outside of the while loop. We turn off highlight execution to see what happens. Here it sort of just runs as usual, but if you notice, unlike the previous runs, when we change the total time in seconds, it doesn't affect our output here. You can see what happens to our input when we toggle highlight executions again. So here, when we run, it passes the value of 900 into the input tunnel. But when we change our input value, it sort of does not take in to the gate over here, or the input tunnel, or change value. Again, as explained earlier, while with our while loop running, while it's running, anything that's passing through the tunnels, input tunnels or output tunnels, will stay there until our stop button is clicked, or until the while loop ends. So let's put our input back inside. And there we have it. This was laboratory activity 3 loops. Thank you for watching.